What's the first thing you do when you're making porridge? Literally the very first thing you do. You carry oats. I'll let myself out. Hello and welcome. Pull up a chair and get nice and cozy here with myself and Fred. Eukaryotes. Every time I think of them, I always think about porridge. Let's see where they fit in the taxonomic ranks. We have life above everything, of course, and then eukaryotes come in right at the top, the highest rank there is, the domain. It's one of only 3 domains and is the one you're definitely the most familiar with. Some notable eukaryotes you might have heard of include ants, bears, cats, dogs, elephants, flowers, grass, humans, iguanas, jellyfish, koalas, lobsters, mushrooms, nuts, oranges, pandas, Queen Elizabeth II, rabbits, snakes, trees, urchins, vultures, whales, xymenia, yaks, and zebras, to name but a few. The earliest evidence we have for eukaryotes is from over 2 billion years ago. That means that eukaryotes have been knocking around for almost as long as The Simpsons. Scientists think that the first eukaryotic cell came about when a prokaryotic cell was shuffling about and engulfed another one, as single-celled organisms are wont to do. And the one who was eaten decided, it's actually a little cozy in here. Maybe if I give a little bit of energy as rent, they'll let me stay in here. And boom, eukaryotes were born. Or something like that. This cooperation between cells is what let the eukaryotes thrive and flourish and grow beyond what was previously possible. A size-limiting factor for all cells and life before was a mathematical principle called the surface-to-volume ratio. Now, we're not going to go into the whole maths of it all, but here's the basics of kind of what it means. The volume is the insides of the cell doing all the business of living. The surface is the membrane which allows resources in and waste out. If the volume's too big, then there's not enough surface area to take in enough resources or excrete enough waste for all the reactions inside. Imagine being both gasping for air and constipated at the same time. Not great for life. This means that cells have a set maximum size limit, which is pretty small and limits growth. Eukaryotes got around this problem by having multiple cells working together to perform common goals. If you have 10 cells together, yes, that's a volume 10 times bigger, but it's also a surface area 10 times bigger because of the surface of each individual cell. As time went on, the eukaryotes went from single-celled organisms like stentors and paramecium, to multicellular life forms like tardigrades, sponges and jellyfish, growing larger and more complex, a bit like my diet at Christmas. Before we jump away from the cell and look at more complex life, we need to look at the actual insides of the cell. We know that all life is made of cells, but not all cells are the same. There are, broadly speaking, 2 main types of cell. You have prokaryotic cells and eukaryotic cells. Now, the karyote in eukaryotic and prokaryotic means nucleus, the nucleus of the cell. And the U means true, so true cell, true nucleus, not true cell. And pro means before. It doesn't mean that prokaryotes are for karyotes. So eukaryotes are the cells with a true nucleus.
Eukaryotes differ from prokaryotes in another way. They have membrane-bound organelles. What's an organelle? Think organ in a cell. Organelle. There are loads of different types of organelle, some specific to different life forms, and some have their own membrane, like the nucleus. Some examples of organelles would be the nucleus. This is where eukaryotes store their DNA. Mitochondria. These are found in all but one eukaryotic cell, as far as we know anyway, and are the little energy powerhouses of eukaryotic cells. They're also the reason why we can feel and interact with the Force.
Without the
Mitochondria,
life could not exist, and we would have no knowledge of the Force.
Isn't that right, Master Fred? And Fred is the least Star Wars name there is. Darth Fred. Here's another movie-related.
Endoplasmic reticulum. Sounds like it's straight out of Ghostbusters, but it's basically the factory of the cell. It's a bunch of squiggly membranes around the nucleus that takes the raw ingredients to make proteins and lipids and then ships them off. Golgi apparatus. This is the delivery service of the cell. They take the proteins, package them up, and send them to their destination. Pretty neat. There are also some organelles that are specific to different kingdoms, like flagellum in animal cells or chloroplasts in plants, but those will be covered in their respective videos. Here we have some footage of an amoeba. This little guy is a single-celled microscopic eukaryote that moves around in a very sci-fi fashion, spreading out in different directions in all kinds of shapes. If you look closely inside the amoeba, you can actually see the nucleus rolling around inside. You might also notice that there's a long, rigid thing inside the amoeba too. That's its last meal, another single-celled eukaryote called a diatom. There's actually one passing by at the moment just below the amoeba. There are plenty of different species of single-celled eukaryote, but the most famous trait of eukaryotes is their ability to work together. This means they can create larger forms of life than the microscopic single-celled organisms. When cells started working together, then each individual cell could focus on one main task and leave other cells to focus on other tasks. This meant much larger systems and much larger life forms.
So he's after seeing a butterfly in the room, and fun and games are going to ensue. Why did I decide to work with animals? I just don't know. If he's not in the rest of the episode, it's because he's in hunting mode. Well, looky here. Believe it or not, this beast is Freddy's father. And his name is Louis. Smile for the camera, Louis. Yeah. I thought I might introduce him in a future episode, but seeing as Louis is away chasing butterflies... Oh, sorry, Freddy's chasing butterflies. And Louis is here, well... Why not, eh? So the eukaryotes grew larger and larger and diversified and specialized until they became what we know today as most forms of life. Animals, plants, fungi and such. Unfortunately, there is just that little and such.
Just like in the life episode, there are issues when we try to define what happened with eukaryotes. I mean, Linnaeus thought there were only plants and animals, and minerals for some reason were on the list too. Then over the years, loads of people started discovering more and more with the birth of microscopy and genetics and cladistics. This means the classification of the kingdoms under eukaryotes are topics of debate, so much so that some scientists don't even use them.
When faced with a challenge like this, just remember one thing. I am a guy chilling by the fire with his cat research assistant. I don't make the rules, I just talk about all this stuff because I love nature. I'm sure some of the things that I talk about will age like fine milk, and some of it's probably already out of date, but that's the nature of it. And when I tell you that the kingdoms that we're going to be looking at are Animalia, Plantae, Fungi, Protozoa, and Chromista? Don't shoot me, it was Fred's idea.
I feel it's only right to talk about cladistics here. This is a new form of classification that focuses on the relationship over time between different species, forming an evolutionary link rather than a grouping based on shared characteristics. The Linnaean system and cladistics are kind of duking it out to see which is the best system. Some people are trying to merge the two. There's still a lot of debate over certain aspects of taxonomy, and in future we might cover these in more detail, but for now, we have to make decisions too.
So, what do eukaryotes mean for humans? Well, pretty much all of our food comes from eukaryotes and all of our air and stuff. And we are eukaryotes. I mean, the world would be completely different if it wasn't for eukaryotes. So it's, again, very similar to the previous episode on just life in general.
Where do eukaryotes live? Again, all over the planet. They're on every continent and in every sea, river, lake, just about anywhere really. There are even some eukaryotic extremophiles, life forms that live in very extreme environments. They may live in extreme environments, but it's been found that eukaryotes struggle to compete with prokaryotic thermophiles, meaning they aren't as amazing at coping with insane heat, but they still can, and the science is a little unclear. Extremophiles are notoriously difficult to study.
So in conclusion, eukaryotes are what happened when life discovered teamwork. And it's fair to say that the whole world would be an extremely different place if they weren't around. I mean, we wouldn't have the whole Fred and Butterfly saga. And we wouldn't have you, eukaryotes. Yeah, okay, probably deserved that. Not sponsored by Cavanagh, by the way. But please don't let my dodgy jokes deter you from coming back, getting cozy with myself and Fred, and learning about life by the fireside. See you next time.